Greetings and welcome to the Pure Report. I'm your host, Rob Ludeman, and it's time to bring the orange with episode 2 of our 15 architectural decisions series that we're doing. Introducing Andrew Miller, J.D. Wallace,
Yo.
Two of my best buddies from the Unplugged edition that we do. Welcome back. If you are catching this series, thank you for continuing on with us. Super fun to go through this. Andrew, say hello to everybody.
Hello, everybody.
That's right. J.D.?
Hey there.
Yeah. Well, let's do this thing. Backdrop, if you missed episode 1, we are going through Pure's 15 architectural decisions in detail and putting them all in one place for everybody. We're talking about what they are and the implications, the impact, as well as a little bit behind the technology. And with this one, we are taking on Flash. And there's a lot with Flash that we can go into, so we'll clarify that, but maybe the understanding of Flash as a media, and then we're also going to look at how that relates to and dig into data reduction, a term that is used quite widely out there and regularly, but what does it really mean? What does it really impact for people that are running storage? So let us dive in and take on the first one of these. Flash, Andrew, you want to hit this one first? Flash, or understanding Flash deeply. There's a long history here at Pure with how we approached it. And if people saw episode 1, we did talk about all the different Flash-based storage companies that there were 15 years ago, and many of them are not here anymore. So
Moment of silence. Never mind.
Okay, no, let's pass on that. Yes, but we're still here. So what about Flash?
So last time we did simplicity. We focused on scale-out architectures. There was even one thing that we didn't talk about there about scale-up versus scale-out, about refreshing media and making it better over time, which of course then brings us to the media. And so we're thinking we're in a little bit of a historical time machine here. So, these started in 2009. So at the time, it was the sense that, hey, Flash was actually potentially this kind of scary media to use. You had to worry about, is my data going to be resilient? There were different kinds of Flash. So when we say understanding Flash deeply, you may remember there was maybe consumer Flash versus enterprise Flash. There was also some acronyms like SLC, single layer cell, EMLC, CMLC, the different grades. It was actually really sometimes about the over-provisioning and maybe not much more than that. So there was this thing as Flash is this new media, lots of companies are betting on it. But the most common way that people were looking at Flash was, hey, can I take Flash and actually make it look like a disk and not have to worry about it, especially
that was the challenge. Yeah.
If you're an existing storage vendor, it's a lot of work to understand how Flash is very different. So let's actually go there for a second in the understanding Flash deeply secularly. So if you have a hard disk, which now you may be listening and you may be thinking, what's a hard disk? I don't have anything in my house with a hard drive. But yeah, maybe you probably do. Maybe for your backup drives, maybe not. But you had spinning platters, spinning rust, if you will. They're running magnetic charges down. You had a physical head that moved around. So if you had to do random versus sequential, if you wanted to do random reads, the head would have to move to all these different places on the platter. If you wanted to do random writes, well, that actually probably wasn't a thing. You actually had systems that started to actually help the writes and actually buffer the writes into turn writes into being sequential. There was a company that had a file system named Waffle that helped do some of that I worked with in the past. Being real, not taking pot shots. Right. Okay. So Flash says actually reads are free and writes are relatively more expensive. So you take the worst workloads for disk in the past, that actually some of the worst workloads would be random reads or lots of different hosts doing random reads because you basically have the head thrashing. That physical head would have to move all around the disk kind of thing, the physical platter. Flash says, hey, I can actually go and do random reads really well because I can check this block, this block, this block, this block all at the same time. Now, the catch is if you're a traditional manufacturer, figuring that stuff out is really, really hard. So there was the evolution of then SSDs. And these were actually kind of like, I think, almost like miniature storage arrays, JD?
Yeah, I think you're really getting to the crux here. We talk about this section, we call it Flash.
Right.
And we are talking about Flash, but I think more importantly, we're talking about the packaging. Andrew, you alluded to many of the challenges with Flash, especially in the early days. Durability was a problem. We had several grades because of that.
How many writes they could handle. You could only handle so many writes before a flash cell would go offline.
Exactly. And the big problem, which was they handle I/O differently. And so we can't just take flash and stick it in a system that was designed for hard drives, completely different geometries at play. And so I think the real crux of this section is packaging.
Yeah.
We package flash into an SSD that looks and smells like a hard drive, and now we can use that and essentially as a hard drive analog. But to do that, essentially every one of those SSDs has to be a little miniature flash-based storage array. And so we've got RAID that goes in there. We've got a controller that goes in there. We've got DRAM that goes in there. There's a lot going on. We call some of that the flash translation layer.
FTL, acronym check. That's the one. If
Yeah.
you're thinking about it.
Yeah.
And so I think this is actually one of the things, we talk a lot about history in this podcast, in this series. This was really kind of the nexus of why I think we had so many storage vendors come to the market in this, 2009, 2010 timeframe, because everybody realized, or a lot of folks realized, that flash was going to replace hard drives. But how we were going to get there was a lot of room for interpretation. A lot of different companies taking that from a lot of different perspectives,
It was
right?
also about what you were focusing on, right?
Mhm.
One of the things I distinctly remember around that time period was going to various industry shows, and I worked for a large database company at the time. So I would go to those shows and you'd walk down these aisles and you'd see just these companies where it was generally just two people.
Yeah.
But the focus was on how many IOPS can I drive, right? I'm driving 120K, yours only is 100, but it was these folks in garages just trying to supercharge flash to drive IOPS. And that was fine for certain workloads, but was there robustness? Was there reliability? Was there wear leveling? Like where are all those things that I think we cleverly figured out in software that you could create something that would eventually make it into the enterprise because it wasn't just focused on turbocharging.
This was the time of come for the performance because
Yeah.
Flash could give so many different vendors a 10x or more advantage in performance. That's why you'd even be willing to try it. Try this vendor, try that vendor. Some of the ones that are gone. So maybe Pure. It's why we would try Pure 10 years ago. Now, there's a great quote that I knew I was going to weave in here somewhere, but I didn't know exactly where.
Of course you were. Of course you were.
Kix, original product manager, and Kaz about come for the performance. That's why someone would try Pure, even when we're a startup, but stay for the simplicity.
Right.
That's why simplicity was the first architectural decision. The reason you'd even be able to get there and see it is you'd come for the performance. I don't want to cut you off, JD. I was going to wander back a little bit to one other characteristics of Flash as far as just durability. Should I go there?
Go for it.
Okay. So we think about a hard drive in the past, and you could actually write to the same sector many, many different times, magnetic charges. You couldn't write to it infinite times, but nobody really thought about how many times you could write to it. It wasn't a factor you had to think about for design. With Flash, you have what's called a program erase cycle because you don't actually write to a full Flash block. What you actually have to do is you have to have an empty Flash block, and then you can write to it, or Flash sector. So if it's already occupied, you actually have to do what's called garbage collection, move all the data off, erase it, and then you can put new data there. That sounds a little bit in the weeds. What matters is you can only do that process, that erase, so many given times per type of Flash, and then it's done. You don't get to use it anymore. Now, so this is different, the number of program erase cycles that you can do. It varies based on the type of Flash, from MLC to TLC to QLC, et cetera. Over time, as Flash gets cheaper and bigger, the number of program erase cycles drops. And so that actually causes a system design problem.
Yeah.
And so you actually get the challenge of, this is especially back then, but still now, of I'm going to write to Flash, and it's really good performance. It's better for reads than it is for writes, but it's good performance. But how long will it last? And then will it last long enough to actually be affordable, kind of thing? So that's what then goes into more deeply understanding how you should write to Flash. And newsflash for anyone who's thinking, oh, you're going to talk about direct Flash modules? We are, but not yet. Because when Pure started out, did we make any custom hardware?
Nope.
Not at all. So I want to take us through some of the original things we did to treat Flash like Flash, even when we were using SSDs from our partner vendors at that point.
Well, the first thing I think I'd like to do is you made some really good points about how Flash is actually built. And for the folks who are listening or watching who want to dig a little bit deeper, I would encourage everybody to go and search for either the Pure Report podcast or the blog series on Better Science.
Yep.
Such a good call out.
We go so deep in those opportunities into kind of some of the specifics of what you're talking about. So
Brian Gold, Justin Emerson.
you want a deep dive, go find those.
You're like, Andrew used the wrong terms. You're right, I might have, but they used the right ones, and they're really good at it.
Well, and you can go back in the history of things. I mean, Flash used to be, I liked it when it was called EPROMs, right? I mean, it's these programmable memories that you have, but that they're non-volatile. And I'm showing a little bit of my dorky semiconductor background, but sync RAM and DRAM, they need a charge.
Yeah.
And these were novel things because you didn't need to have voltage to keep the cell activated, and it would keep its state. And so that's why it became very interesting as an alternative to disk. I mean, even some of the drawbacks that you were just mentioning about, or challenges with managing flash at scale with cells wearing out, think about the contrast to disk drives, right? And the challenge that are presented there just with sheer physics, right? I mean, the reason we still have the same 15K RPM drives that we've had forever is because you can't spin them any faster and still maintain the data that's on them. That's a big challenge. And so
Cannot break the laws of physics.
Physics always wins. We always had that. Was when I was at another company where they're trying to build a 10 gigahertz microprocessor. Guess what? It's really hard to move an electron from A to B at the speed of light. And so physics always wins, but that's why Flash became so exciting when we jumped in. And it was a matter of the engineering of what you guys said, the FTL, the flash translation layer, and ultimately understanding that software was going to unlock the advantages that we could get out of Flash, and then custom design, like we have here in front of us.
But I want to answer your question.
Yeah, sorry.
No.
I went on a jag.
I've got a Charlie story and another one, but keep going.
Yeah.
I think you actually set it up really nicely because we talk about all of this and there's a little bit, Andrew, doom and gloom, right? You just highlighted a ton of problems with Flash.
It was hard, not easy.
And so the crux of this decision was, are we going to continue to use that very expensive top shelf, what was called at the time, enterprise grade Flash? And if you didn't think about solving those problems differently, that was a very easy way to solve that problem.
It may be the only way.
I know I'm going to have reliability challenges. I know I'm going to have endurance challenges. So how do I solve that problem? I'm going to put in the most expensive top shelf Flash that I can get to essentially buy me enough time that I don't have to worry about those problems.
Let someone else solve those problems for me.
Let someone else solve them for you. Exactly. And that's what almost everyone in the industry did at that time. And this is where we're really different because we took a step back and said, okay, if we can think architecturally different about how we treat that media, if we understand that the program erase cycle that you talked about, Andrew, if I understand that fundamentally these cells want to be talked to differently, and I can engineer a system, and this is really where this is system think, right? How do I engineer a system?
Systems design.
To address the media the way it wants to be addressed. And if I can do that, I don't need to solve that problem with expensive, quote unquote, enterprise grade Flash because I solved it a different way. And now that I've solved it a different way, I can use a different grade of media and still get the same value. This is the FUD factor back in that day, right? People were coming in and saying, Pure, you're using quote unquote consumer grade Flash. You're not, you're using a cheaper product.
Right.
No, I'm not. I'm solving the problem a different way. And that's really what it boils down to.
You know what's fun about being on video right now?
What?
Is you just did air quotes.
They could see him.
First time somebody could actually see air quotes. And the other quote that comes to mind, I've been using this in some presentations recently, is we didn't do this because we didn't do this because it was easy. We did it because we thought it would be easy.
Yeah.
Right. That whole kind of adage. Sorry, Andrew, go ahead.
No, there was a gentleman actually who's at Pure now. He was at Pure for quite a while, and then he wandered off to do some other cool things, and then came back. Michael Cornwell. He was actually involved in putting Flash in the iPod, and so had a really good perspective on consumer grade Flash. And there's actually a spot where Kaz, founder of Pure, talks about how MC, because YMC kind of educated him around some of this stuff. And there was also this secular bet on the price curve of consumer flash going down, and now you can
Was
see my
huge.
gestures. Yeah,
That was a big deal.
so that we were saying that if we do this pretty hard engineering work, that the cost basis of consumer grade flash, now insert everything that we know that's happened in iPods and iPhones and iPads and the just prevalence of consumer grade flash, that engineering is going to pay off in spades.
Mm-hmm.
So while Pure started with SSDs and understanding the SSD flash translation layer really well, we were setting the groundwork and thinking about it not as just, okay, we're going to outsource this engineering problem to someone else. We're going to try and solve it in a way that can get us and our customers outsized advantage. And if you're thinking that's setting up for direct flash, where we don't actually buy SSDs, but we get the raw NAND and, hey, visual demonstration. That's why I had it sitting on the table here. If we actually want to make a direct flash module that actually kind of looks similar physically, size-wise, but it actually is just the NAND and our own very trimmed down flash translation layer with the controller understanding and seeing all the NAND directly, that's absolutely what we're leading into.
Mm-hmm.
I feel like I'm about to go into why customers care about this, because we spent a lot of time on the problem and the solution. Should I go there?
Well, we geeked out a little, which is fun, though, because I think there's varying levels of understanding just about flash as a medium, and people hear it, but getting into a little bit of the deep dive, nerdy chip stuff is kind of fun. But let's do that translation mechanism. Like, why does this matter? You mentioned the cost curve. That's obviously a really significant one, because there were periods of time, certainly, where there were certain workloads that were not optimal for, like, why would I not use disk for long-term archive repositories? Flash is too expensive, right? For things that I'm just going to have go sit because of compliance or retention reasons. So there's that cost component to it. But then why else then does this matter to customers?
So there's a cost component, and ironically, I'm going to put some thoughts here and then save a little bit of it for the next decision, the data reduction one, because even back then, Flash was actually still really expensive for a tier 1 application. But treating Flash natively gave you the longevity and the performance, so you could actually unlock more performance out of the Flash in various ways, so you could push it even further. But frankly, there was probably enough performance even in SSDs at the time.
It probably was.
The longer-term benefit was if you say, hey, I can keep a disk drive for 3 to 5 years maybe. I had some in my data center that I kept like 6 years, and you knew they were going to flake out. But if you can treat Flash the way it wants to be treated, that sounds like any good. Sounds like we're into like
Like the golden rule.
into like relationship counseling territory here or something. I don't know. It's like I jumped so. But if you want to actually leverage Flash how it is built natively, you can get far longer endurance out of it. Mm-hmm. And then that turns into really interesting things about, instead of something lasting 3 or 4 or 5 years, could it last 8 years? Could it last 10 years? Could it last 15 years? When we were working on this at the beginning, I don't think anyone knew for sure exactly how long we can make that longevity thing last. We've now got data to put it in the 10 to 15 year range and maybe longer in some cases. With one large organization, we actually have some numbers wrapped around that because we've seen enough data to guarantee that. But so you think about taking the most expensive component in a system and making it last dramatically longer, thanks to really good engineering. Well, that benefits customers. Mm-hmm. And we're starting into a little bit of the evergreen, not having to migrate data. If the media doesn't wear out, that's one reason you don't have to migrate
I'm pretty
data.
sure we're going to touch on evergreen every one of these until we get to the evergreen at the end, which is fine.
We're going to thread it through.
It is super foundational. Yeah.
And then there's some pieces just around economy of scale that we were riding the consumer flash curve. I feel like we might have drained that one, JD. Anything else you want to put in there before we wander into number 4?
Well, I mean, I think I've got a good thought to kind of help us with the segue a little bit.
Ooh, even better.
I like a good segue.
So we've talked about how some of these tactics allowed us to lower cost. Mm-hmm. And as a startup, that's very valuable both for us as a company and for the consumer in the product that they're buying. But these tactics alone were only going to get us so far. These tactics alone allowed us to compete with other all-flash vendors.
Well stated.
But we had a desire not just to go compete with other workloads that were already going to run on Flash. We had a desire to eradicate disk from the market. And we're still on that journey, but
way further along.
We needed more. We needed more to bring that cost curve down dramatically enough that we could start really going after disk-based solutions. And it leads us really nicely into the next architectural decision,
Yeah.
was to focus on data reduction, deduplication technologies.
And that was the one coming in that I was most, I don't know, surprised isn't the right word, but coming from a database background
Mm-hmm.
where I came in here and, oh yeah, okay, data reduction, no big deal. And they said, no, let me sit down.
It's a big deal.
Let me show you not just the one thing that we're doing, but the multitude of things that we are doing, because it's a spectrum. It's not, okay, we're doing dedupe better than somebody else. And there's far more to it that's just scratching the surface. And that was what was most impressive. And then the fact that we were actually at one point, you could go to our website. I don't know if you guys were here when we did this, but we had a live data reduction ticker.
Like total data reduced.
A data reduction ticker that we ran, and I don't know, I'll simulate, maybe it was live. I'm not sure how we did it. Maybe it was Memorex, but we definitely had that. But then also to look at the different ratings, and everybody knew them, right? It was like, okay, you're running Oracle, you're running SQL, 3.6 to 4 to 1 reduction. Oh, VMware, okay,
On average,
8 to 10 to 1. On average,
BDI was crazy that way.
yeah,
really
non-prod, just whatever
Yeah.
data, 10 to 1 on average. I'm like, how are we doing this? So how are we doing this?
So there's some pieces that we were doing in Decision 3 around bundling large writes together and I/O scheduling. Okay, that's foundational. If you want to make Flash last longer or make it potentially less expensive, this isn't cheap. This is less expensive. It's the even better thing than writing data intelligently is not having to write data at all. Which actually sounds a little scary. You're saying, like, what are you doing to my
Where's it
data?
going?
Like,
Where's it going?
you're a storage array.
Yeah.
Like, I'm giving you my data and it's really secure and safe. And okay, so let's talk about kind of data reduction, aka efficiency, and doing this on all the data all the time. And this, by the way, is there's a piece here that's historical, and then there's a piece here that actually enables where we've gone with kind of as a service, even consumption models too. So we'll get to that as we go along the way here. So, but let's just start out with, we'll try and wander back to the what it is and what it does, kind of thing. So this is where when you look at a flash array, and we're focusing on flash array for these architectural decisions, some of them apply to FlashBlade as well, but there's the idea of data reduction, and that it is inline and post-process, and that it is with deduplication and compression. So this is where we're not going to try and use full-on slides, I think, in the podcast here, but this is where you and I, JD, have sometimes done kind of like a life of an I/O, and there's all these fun diagrams and things move around.
There's some
float.
really great visuals around this. So
Yeah.
maybe we'll look at post and see if we can put, because it would provide some good color commentary.
So as data, but I'll give an audio-ish, and I'll wave my hands around a little bit, and we'll see how well it works. So as data comes into a flash array, this is some of what it's doing. We're actually looking at that and saying, first, is there any filler data? Because sometimes when you send blocks into a flash array, it's actually white space at the end. So you go ahead and you knock that off. Then we're doing some lightweight pieces around inline deduplication. We're actually going and looking for common blocks. And then we're even doing some inline compression as well. Now, we're throttling that because the first thing that we should look at is, can we keep up with the performance requirements that we're sending you? But we just talked about Moore's Law, and there's usually a lot of CPU out there, and we can leverage that because the less data that we actually have come in after the inline processes, the less we have to write to flash at all. Now, we'll talk about resiliency later as far as some of the protection there. And then, but let's say, for instance, that actually the array is really busy. We shouldn't say, oh, no, you can't send us any data because we have to do all our inline stuff, kind of thing. No, there's actually some variability of some of it inline deduplication and compression happens up front. But if the array gets really busy, we will come back later and look to see either maybe we deprioritize those processes to do what matters to you, take your writes in, or we'll even come back later with deeper compression algorithms based on the data type when it stays around. Is it worth spending a lot of CPU on data that may be kind of ephemeral to get deeper compression out of it? No, but you could have multiple compression algorithms. I think the last piece before I tag you in a little bit, JD, is there was often now this is going back 15 years ago, the concern about hash collisions, because deduplication today is not as scary, but then it was like, it started on backup data, and there was a startup there that got inquired by EMC, no NetApp, no EMC, that went back and forth. Remember that one, right? Kind of thing. So
you might have to qualify a little bit what a hash collision is.
Yeah.
So the idea that when you go and look at a piece of data, and you make a hash, and often an MD5 hash, keep me honest, that could actually be, you could get the same MD5 hash or checksum, if you will, for one piece of data, possibly, maybe 1 in a million, as another piece of data that's actually different. So what Pure actually did was we actually went and said, hey, we're going to use checksums to go and try and look at this inline, but then we're going to do a byte level comparison before we say, oh, this is actually the same piece of data. We only need to store it once, because by definition that says, hey, you sent us the same thing twice. We're only going to store that thing once, and we're going to do a metadata map. And if you're thinking that's another architectural decision, you're right.
It is.
Can't help but foreshadowing kind of thing. So there's this intelligence here about inline, post-process, deduplication, and compression, and leading down to actually eventually writing less data to the flash, which helps with flash performance, but also it helps with flash longevity too.
Mm-hmm.
And
There
there's
is
a
an
lot of
implication there.
engineering in here.
Yeah.
So you said a lot of really great things there, Andrew. But if
I
I
got
could
going a little long.
let me take it up one level and just kind of reset a little bit. So again, thinking historically, I remember these days, and there were lots of debates. Each individual company only has so much that they can invest in R&D to get their product out the door, to be successful, to grow into a business that is surviving and thriving. And so at this time, there were lots of debates around, well, when do you do your deduplication? Is it is it inline? Is it post-process? Which one is better? And I think the core of this architectural decision for me was that we realized this was such a huge strategic advantage. It was worth investing and doing all of it.
Intelligently, balanced.
I'm going to need inline. I'm going to need the ability to back off that so I can do some post-process. I'm going to need compression and deduplication. I'm going to need variable
let's
block
go there.
size.
You want to go there?
deduplication.
Love the variable block
Do it.
size.
All right,
yeah.
good.
So who remembers alignment? Hey, I'm going to create a volume for my particular application. Well, what is the block level alignment?
What is the offset based on the file system type? And it could be different depending on the file system, I think.
And if you got that wrong, then all your deduplication went out the window, because now there was no alignment. Nothing actually matched when we were doing those hashes that you talked about.
And you wasted a bunch of time.
And you
doing
just wasted a whole bunch of time.
You had to do it, or else you didn't get good deduplication. Or if you forgot to do it, or maybe you didn't control all the people in your environment because you were a big shop and you couldn't tell everybody to do it the way they should do it.
Right.
And this goes back to our architectural decision of simplicity.
Right.
You shouldn't have to know. You shouldn't have to make those decisions.
Right. Yeah.
So we just said, hey, we're going to look at everything. We're going to have a sliding window of where we're going to start to match those blocks. And this is where the visual really helps. So we'll add that later. We're actually going to have a sliding window where we're going to look at those bytes as they come in. And when we find a match, we'll start to search on either side of that to figure out where the duplicative data exists.
Commonality, how large
commonality
it is.
exists,
Yeah.
and give you the ability to match that data no matter where it is.
There's even some neat stuff there about where it's actually a 4K, it's 8 sectors, 512K, and then it expands in 512K, and it's actually a sliding thing. So this is, again, is the visuals, but trying to figure out, okay, because I actually worked with a system where it was 4K fixed block. And if you didn't think about that stuff, or I actually sometimes would go in and do professional services in a previous life to help migrate all these things around so the customer could get way better dedupe. And it's like, for me at the time, I was like, oh, this is just how the tech works. And I'm getting paid to do overnight migrations for this stuff when I was at a partner.
Or even worse, some products at the time, if you knew you were going to be if you knew you were going to be hosting an application that had small block I/O, you would literally turn off deduplication for those volumes.
Yeah.
You can have it one way or the other. You can either have large blocks or you can have duplication. Which one do you want?
Right.
And that sounds like another decision you have to make, something you might find out after the fact. Whew. So this is even an architectural principle, by the way. Now, this is pulling off of simplicity. If you have to have this level of decision trees around deduplication, compression, large block, now you start to have all these different silos inside the array or between different arrays. So there's this piece of actually how we approach data reduction enabled the consolidation of workloads onto Pure systems that wouldn't have been possible before. Now, there are performance aspects there. We'll probably come back to that later about, some always-on quality of service to keep from noisy neighbors from impacting. But data reduction actually allowed different types of workloads that before you would have had to manually isolate and plan out ahead of time and know what's coming. You don't have to think about that.
That was one of the more enjoyable projects when I first started here. Was I got assigned to go and hire ESG to do a lab validation.
Yeah.
And we were scoping out what were the workloads that we wanted to run. And I was concerned. I was new. I went, we can't possibly put all these things on one flash array. And the team said, no, we did one of these a couple of years ago, right? This is what we are designed for. This is what is in the Purity operating environment to do. So go get some Oracle, go get some SQL Server, go ahead and virtualize it all. We had a solution architect at that time mucking around with SAP, and okay, cool, we'll run that in the app layer. And we went and ran this VDI too, right? And when it's like,
All that
how
on the
is
same
that
box.
going to work? How's that going to behave? And just at the data reduction level, and I'm probably getting into one of the other things, but it was actually the look at the latencies and the consistent levels of performance delivered that were most impressive, largely because of the ability to handle these different block sizes and things like that. But it was consistent latency, and I was blown away. But it was a really fun project and a great example of, how we can consolidate, right, and put a lot of workloads onto one array and not have differing performances, but also not have to do like getting into the what's in it for the customer.
That's
You
part
don't have
of
to
it.
buy as much storage, and furthermore, you don't have to do all these mundane tasks that you were talking about. That sounds nightmarish with having to do all that mapping.
There was even a really fun story. Now, I think we're wandering our way into why do you care and customer
it's
value.
about time for why.
The when I mentioned in the post process where there's compression as well, there's actually multiple different compression libraries in there. There was actually a release of Purity. It was before I joined, so it's been a little while, where they actually added a new compression library in. And I heard stories actually when I joined of actually customers calling in after they had upgraded to this release of Purity. Purity is the Purity OS, the software that runs FlashArray and FlashBlade, where actually they saw their used space decrease after the upgrade. And that could actually be a little bit scary.
Where'd my data go?
It's like,
Right, yeah.
So actually there was a new, because there are multiple compression algorithms in them. Some of these are open source items. Some of these are things that we license, et cetera. So we leverage this, but not full disclosure because there's sometimes our legal boundaries around the licensing terms. That actually put a new compression library in that was actually getting better performance for certain types of data. So actually, do we promise this every time? No, but there truly was a case where multiple customers actually had less space and maybe they needed to buy disk for a little while. There's this magical thing about data always grows. So like doing the right thing by customers still works out eventually because you still need more disk, right? Kind of thing. Or flash. I think disk.
Flash.
Yeah.
No, but we would have
Data.
we would have on certain slides. I remember we had the acronym YMMV. Your mileage may vary, right? That was actually there with an asterisk, just to be fair, just to be honest, right? That there is some variation in workload types, but certainly those are some of those fun magical things that happen, right, with the upgrades.
And I know this is a podcast about architecture,
Yeah.
but what you said, I have to bring up culture a little bit because what you said really plays into the culture of Pure, because I know from those days, the direction from leadership was, hey, we are not going to negotiate on our data reduction. We know what it is.
Yeah.
We're confident, and I'm not going to go in and artificially tune that number to try to go win a deal against a competitor. Our goal was we are going to undercommit and over-deliver so that our customer is always delighted. And I think that speaks to company culture.
And it was always a great outcome. I always loved that when we would go in and we would it's Oracle database. Yeah, you might see 3. And they'd come back and go, we have 3.8. We have 4.2.
Mm-hmm.
Oh, fantastic. Well, what do you think about the rest of the experience? Oh, okay. Yeah. Well, I love that it does this, back to episode 1. Oh, it's super easy to use. We got it installed in a half hour, on and on.
So the engineering work there, and actually I'll keep pulling that thread, JD, there is what we introduced called a right size guarantee, which is somebody says, you may still say today, a customer might say today, I don't know what level of data reduction I'm going to get. Pure will actually sign a right size guarantee. If it's a actually pretty short. I want to say like 2-page legal document that says we've scoped out stuff. You've agreed with the data you've provided, and we will say that you'll get this level of data reduction on the data. And it's a level of confidence in our engineering, but also risk transfer. So if you're outside some of those boundaries, and of course there's like if you're doing crazy stuff that we find out later, you didn't know. Okay, there's boundaries around that, but it's so you can have a level of confidence in data reduction. But then it even goes to, well, let's say if you're writing less data to begin with, that actually can lead to lower failure rates, where we started 10 minutes ago with program erase cycles. You need fewer of those. So it's not just writing to the flash intelligently, it's actually just writing to it less at all. So that's both helps with the total amount of data you need to store and the longevity of the flash. It also, in some cases, actually has allowed us to use various flash technologies sooner than any of our competition. So this is where kind of the technology engineering gift that keeps on giving. So actually, when you and I started, Rob, I think one of the earlier projects we did was talking about Flash Array C, which leveraged QLC,
Right.
a bigger, less expensive, far fewer write cycles. That's the hard engineering part. We were able to leverage that several years earlier than the competition in a storage array because of that work. And so that's a competitive advantage for us, but it's also for customers. Like you could take advantage of the technology that much sooner, kind of thing.
That's good. Anything else, JD? I feel like we've hit this one and the first one in this episode in pretty good depth.
I think that was good coverage.
For the propeller heads out there, they're going to love this because we did go into a lot of detail.
There's
But
real stuff here.
But we don't talk about this at this level of detail as much, right? As we used to. I think it's assumed or people know it, and it is still super interesting, right? When you dig into the different techniques around that, when you dig into the history of how we've utilized Flash and evolved with the different types of Flash coming out and then moving into where you have something custom, there's a bunch of great stories, and it just shows the continuous focus on innovation.
And there's even the sense to some degree where maybe 10 or 15 years it was like, oh, deduplication, data reduction, compression. I want to understand all that because it's kind of scary. Now sometimes it's almost easy to take it for granted, but
Right.
we still see both the engineering that we've done in the past and we continue to do. We continue to get better results out of this than our competitors. And I know I'm getting a little competitive, but like this is many, many years of investment. And that even leads forward into, I don't think we'll hit this too much here, but like why we work with AWS and with Azure.
Yeah.
Why you have a software-only version of FlashArray, just like it started. It was software-only running in the cloud. Some of these data reduction work that's been happening for 10 years, that's valuable in the cloud. So there's this outsized benefit where we keep finding spots where, ooh, this helps out customers.
Yep. Love it. Last thoughts? Are you good?
You know what? I think that's
That's a wrap.
a wrap
Awesome.
on that one.
Well, we'll call that a wrap. And thank you, everybody, for listening to this episode 2 of our 15 architectural decisions, where we covered Flash, we covered data reduction, and as always with the Pure Report, tell a friend, tell a colleague, and we will keep the great content coming out. And we hope you're enjoying the firsts of this video series. And with that, we will wrap. For Pure Storage, for my good buddy J.D. Wallace and Andrew Miller, this is Rob Ludeman saying, don't look back. Something might be gaining on you.